Your eyes are probably twitching more often than you notice. Known as myokymia, this involuntary flickering of the eyelid muscles can occur for days or vanish within minutes. But why does it happen? The process behind this twitch is rooted in the tiny nerve endings that control your eyelid muscles. These nerves are highly sensitive and can misfire with minimal provocation. Stress, caffeine, and fatigue are common triggers. Surprisingly, studies have shown that even a subtle change in sleep patterns can spark this response. Despite its frequency, eye twitching holds a more complex purpose than merely annoying you. Let's explore why. Eye twitches are a universal experience, yet their reasons are hardly universal. Your nervous system is constantly on guard, interpreting signals and responding to stimuli. When your eyelid quivers, it's a sign that your facial nerve is sending mixed signals to the muscles. This delicate network of neurons is easily thrown off by lifestyle factors, such as the 200 milligrams of caffeine found in a typical cup of coffee, which can stimulate extra nerve activity. In contrast, dehydration can lead to electrolyte imbalances, causing nerves to misfire unpredictably. Your body's constant adjustments reveal a hidden layer of complexity beneath this common twitch. Your eyelid muscles are remarkably sensitive to the slightest disturbances. These muscles are controlled by motor neurons that communicate through tiny electrical impulses. When stress hormones like cortisol surge, they affect your entire nervous system, including these motor neurons. This heightened state of alert can lead to sporadic contractions felt as twitching. Interestingly, over 70% of twitch episodes occur in the lower eyelid, which has more muscle fibers. Yet, what seems like a simple reaction is actually your body's attempt to maintain balance and function under stress. Environmental factors can turn your eyelids into a dance floor of involuntary movements. Exposure to bright screens increases strain on the eye muscles and nerves. In a 2018 study, individuals using digital devices for more than 6 hours a day experienced a significant rise in twitch frequency. This is because the constant focus and glare force your eyes to work harder, sometimes overwhelming the nerves. Additionally, windy conditions can dry out the eyes, prompting more rapid blinking and resulting in muscle fatigue. Your body is constantly adapting to external pressures, often manifesting as these subtle twitches. Eye twitching serves a fundamental yet enigmatic role: communication. It's your body's way of signaling that something isn't quite right, urging you to investigate potential stressors. Whether it's an excess of caffeine, lack of sleep, or prolonged screen use, the twitch highlights an underlying imbalance. But why the eyes? They are one of the most energetically demanding organs, processing light and information constantly. Thus, even minor disruptions can ripple through this system, showcasing how sensitive nerve and muscle interactions maintain your body's equilibrium. Through understanding these signals, you gain insight into the delicate symphony of your nervous system. Inside your eyelid, the delicate ballet of nerve and muscle creates the phenomenon of a twitch. Motor neurons, the tiny messengers of movement, relay signals from your brain to your eyelid muscles. These signals travel as electrical impulses, moving at speeds of up to 120 meters per second. When these signals misfire, even slightly, the synchronized contraction of muscle fibers is disrupted, resulting in a twitch. This misfiring is often triggered by external factors like stress or caffeine, which alter neuronal firing thresholds. Yet these small errors in communication are usually self-corrected by your body, maintaining overall stability. At the cellular level, muscle fibers in your eyelid are composed of actin and myosin proteins. These proteins interact in a sliding motion, powered by ATP, the energy currency of your cells. When a nerve impulse reaches the muscle, calcium ions flood the area, triggering the actin and myosin to slide past each other, shortening the muscle fiber. A twitch occurs when calcium ions return to their storage compartments unevenly, causing a rapid, repeated contraction. This entire process from impulse to contraction happens in milliseconds, highlighting the remarkable speed of human physiology. The feedback loop between your brain and eyelid ensures that twitches remain brief. Sensory neurons relay information back to your brain, indicating the state of muscle contraction. If a twitch persists, your brain can adjust the signals in a bid to restore normal function. This loop involves neurotransmitters like acetylcholine, which precisely modulate nerve impulses. When in balance, Acetylcholine ensures smooth muscle contractions, while imbalances can lead to persistent twitching. This constant monitoring and adjusting keep your nervous system functioning optimally, even amidst external pressures. The role of ion channels in nerve function is pivotal. These microscopic gateways in nerve cells control the flow of ions such as sodium and potassium, which generate electrical impulses. When these channels are disrupted by factors like stress or fatigue, the timing of nerve signals can falter. This disruption can lead to asynchronous firing, resulting in muscle twitching. An average nerve cell contains thousands of these ion channels, each opening and closing up to 10,000 times per second. This intricate dance of ions underpins the precision of your nervous system's operations. The autonomic nervous system, responsible for involuntary actions, plays a subtler role in eye twitching. It regulates the tone of your eyelid muscles, adjusting them according to your body's needs. When you're stressed, the sympathetic branch of this system kicks in, releasing adrenaline. This hormone primes your body for action but also makes nerve signals more excitable. This heightened excitability can tip the balance, causing twitches. Conversely, the parasympathetic branch helps calm your systems, reducing twitch frequency. This dynamic interplay maintains your body's readiness while preventing overstimulation. Eye twitching rarely signals a serious problem, but when it persists, it might hint at underlying issues. Persistent twitching, lasting more than a week, can indicate conditions like hemifacial spasm. This rare disorder affects about 0.008% of the population. It involves involuntary muscle contractions on one side of the face, often starting with the eyelid. In these cases, a blood vessel pressing on a facial nerve is often responsible. Identifying such a condition early can prevent complications and guide treatment. Thus, while most twitches are benign, persistent or severe cases deserve attention. Stress can amplify eye twitching to its breaking point. During prolonged stress, your body releases cortisol, a hormone that keeps your nervous system on high alert. This hyperactivity can lead to chronic twitching as your neurons remain in an overactive state. In extreme cases, this can cause myokymia to spread beyond the eyes, affecting other facial muscles. The body's stress response creates a feedback loop where increased twitching causes more stress, potentially triggering a cycle of worsening symptoms. Breaking this cycle is crucial for returning to a calmer, twitch-free state. Nutritional imbalances can also drive your eyelids into a twitching frenzy. Deficiencies in key minerals like magnesium and potassium can disrupt nerve function, leading to muscle spasms. Magnesium helps regulate muscle contractions and nerve impulses, while potassium balances electrical signals in nerve cells. A 2015 study published in the Journal of Clinical Nutrition found that increasing dietary magnesium reduced twitch frequency in 80% of participants. Your body's need for these minerals underscores the delicate balance required for proper nerve function. Correcting these deficiencies can often ease persistent twitching. Sleep deprivation is a notorious trigger for eye twitching. When you don't get enough rest, your nervous system suffers. Sleep is crucial for repairing and recalibrating your neurons. Without it, nerve cells become overactive, increasing the likelihood of involuntary muscle contractions. During sleep, your brain processes electrical impulses, effectively resetting neural circuits. Cutting sleep short interrupts this process, leading to increased twitching the next day. This shows how integral sleep is to maintaining stable nerve and muscle interactions, a core component of your body's daily rhythm. The most surprising aspect of eye twitching might be its evolutionary roots. Some scientists suggest that twitching serves as a micro-warning system, alerting you to potential stressors. This minor annoyance could have historically signaled a need for rest or a change in behavior, helping early humans recognize and adapt to stress. It's a subtle reminder of your body's innate wisdom in preserving balance. So next time your eye twitches, consider it a gentle nudge from your biology, urging you to listen and respond to your body's needs. It's a fascinating glimpse into how interconnected your nervous system and daily life truly are.